just going to introduce, this is Doug Aulson. He's my father. I'm just going to tell you a little reasons why you should listen to what he says. He got an industrial engineering degree, and then he owned a business called Automated Machinery. And he traveled around the tri-state area, Pennsylvania, Jersey, Delaware, and automated machinery. Big machinery. And while he was doing that, he got to know
I was
Larry
a
Seipel.
lot younger then.
He got to know Larry Seipel down in Maryland and built some machines for him. So he ended up working at ProWorks, and now we own our own inlay company. And because of our niche industry, things that we want don't exist. So, and then in the beginning we kind of had this money thing, So we've had to do a lot of inventing over the years, and some of the ideas are really good. So he's usually the smartest guy in the room, and sometimes he's a jerk about it. But feel free to interrupt and ask questions because he loves that.
Thank you so much, Dan. Thank you. Thanks.
Okay.
So early on with this conference, we were kind of nervous about it, about having speakers and not having enough people and what was going on. So I said, all right, I'll do something. I'll talk about CNC. And they said, okay, well, what are you going to talk about? And Jamie said, well, how about just MacGyvering? I said, okay, well, that's good. But I thought I would come up with a topic about dust and what I do to design things to help contain it. And that's kind of what my topic is on this discussion. But we can take it wherever you want to go with it. So if you have a question and we get off target, I'm okay with that if everybody else is. So whatever you want to do, we'll do. But I'm going to try and focus on my presentation. And we can go to the next one. So this is a machine that you can purchase. They're relatively inexpensive, and sometimes they actually work well.
You want to tell them where the name came from?
Yes, the Thumper is the name of the machine, and all our machines have names. But this one, we got an order. We first started business, and we got an order, and we had to fill it. So a friend of mine, Dan James from Joss Q's, I called him and said, I need to get a machine. He says, this place in Chicago's got them. He said, you go see them, and they're great. I said, okay. So I go out there, I fly out on a Wednesday, and look at it, and while it's running, I hear this thump, 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 and I asked the guy, I said, why is it making that noise? He said, well, I don't hear anything. So it ended up that I found out it had to do with the computer that he was running it. Because I basically disassembled the whole thing and I couldn't find the vibration. So I ended up buying it, and I said I need it Friday. So it did. It arrived. I flew back that day. It arrived on Friday, and Saturday we were making parts. But when I'd arrived, I called my friend Dan. And I said, Dan, I got it. He goes, well, cool. How is it? And I says, it's okay. It's working good. He says, good. I think I might get one now. I'm glad you tried it out for me. But the topic of the dust, you can see that there's neoprene that's. Oh, geez, you know what I have? Do you have that folder?
Yes.
That's great. This will tell me what I'm talking about.
So what does the machine actually do?
Can you go to the next? There we go. Now looking at the side of it.
Oh, I see.
It's a moving gantry, and what I was thinking was rather than talk about building machines, I was thinking most people here, if you're going to get into CNC, you're going to buy something, and this is what we did to modify this machine to try and contain the dust. So if there was not a cover on the back, We have, you can see where the spindle is, there's some nozzles that we use air to blast the tool to keep the tool cool and dust away. That dust would be flying backwards or going everywhere and getting places you really don't want it to be. And health-wise, it's not so good to breathe dust, and nobody really wants to wear masks all day long. So what I did was I took some plexiglass and bolted it on the side. I cut it in a way that would go underneath the gantry, and put it on both sides. And then I got this neoprene, which I have some specs on it if you have any interest in that. But it flopped in the middle, and it wasn't working. I even put a weight on the back to try and cause it to be tight, but it still kind of bowed down in the middle. So I went to the local hardware store and got some little aluminum U-channel, and bolted it underneath. We'll see a little bit further on. We can go to the next one. That one is, we can go to the next one on that one. So looking directly down into the chamber, that was the effect that I was looking for, was to try and contain this dust. And on the other side is the dust collector. So the idea was to create a negative pressure atmosphere that would want to draw things into the chamber. And it's worked pretty well, and you can see it's pretty MacGyvered, using plywood and nails and screws, and I kind of built it in an afternoon because it needed to happen, and I did use whatever was available. The rollers and the bearings and things I got from Granger, and just kind of MacGyvered it together, and it worked, so I didn't have to do any more. And so you can see the screws on the underside, screws and washers that I did tap the holes into the U-channel, and just use an awl to push through the neoprene, and that's been working now for 12 years. This is the specs on the neoprene. So what I found was I had used HVAC fittings. And I thought that was going to be perfect. It was going to work great. And it did, way better than what we had before, which was nothing. And then what I found happening, that as we blew air into the dust chamber, it would kind of come back out, undesirable. And so I thought, well, and the dust was accumulating all around that opening. And I thought, why isn't it just falling in there? Because it's got the suction coming in. Why isn't it just falling in? Well, it just wasn't. So on other machines, which we'll see later on, I came up with the hopper idea. And I looked everywhere. There's all kinds of hoppers, but there were none that I needed. So I thought, well, let me just get some masonite that has that smooth surface on the outside, on one side. And I got in my CAD system and drew this thing up because I didn't know what the pieces would look like or the angles that were needed, and because I also had to fit it into certain areas. So I designed it and then fit them together, put tape on them, and then fiberglassed it. And again, this one hasn't. This machine hasn't shut down long enough for me to install the hopper, but we will see some later on. So this is another machine we call I'm sorry.
Just one question. What size is that machine, the last one, so I can kind of get how big that pipe is? I'm trying to scale everything, but I don't know if it's a 4x8 or a 3x5 or whatever.
How big is the
How big
table?
how big is Thumper?
Thumper is a 2x3, 2 foot by 3 foot.
Okay, that pipe is not as gigantic as I thought. thought. Thank you. Appreciate it.
T2 is the second thumper. It didn't thump to begin with, but it's a similar design, and so we just, instead thumper 2, we just call it T2. T2, when it came in, it was a different machine than T1. T1 was okay. T2 was a piece of crap. It was terrible. So you can see the gray table underneath. I had to do away with the table that it came with because it couldn't cut a straight line. So I ended up getting a precision ground surface table, which this company in Chicago, they make machine bases, and I think it might have been $1,000. But it's precision ground within 2 thousandths on the top, and I used that as the new base for the machine. I took the Thompson rails that were on the old machine, on the old base, transferred everything over. I had to change a little bit on the gantry to incorporate the table, but it ended up that after putting that new machine base on there, it's incredibly accurate. It's my coworkers, they enjoy using it. But this dust chamber, because it's a little bit different machine, needed to be a little different. So to create the chamber, I used some aluminum angle on the sides, and then put another aluminum angle on the top. You can see it better on the right there, as a surface to mount the plexiglass. The reason I was using plexiglass is so that light could get in, and so you could see better what your work is. Because it's kind of nice to be able to have light coming from the back side as well as just from the front side. And we can go to the next one. So you can see a pretty good MacGyvering there. I had some 2x4s and some.
What are the bearings and pulleys for? Just so it rolls up and roll? Oh, it's got to be able to move when the machine moves.
Yes, when the machine moves, and you can see at the bottom there. Basically, I think it's on this one, it's just a steel rod that I took the end and just folded it up, and it does what it's supposed to do. The plexiglass, I mean, I just cut it in a table saw, the sizes that I needed, and then took a file on the edges to get any sharp edge off, because I didn't want the plexiglass to have a wearing problem. And it, as long as the surface is smooth, the neoprene just keeps right on going. I haven't replaced any of it at all. And you can see this is kind of like a modified hopper.
Do you have any dust collection right at the spindle?
No. That we just have the air nozzles.
Okay.
I thought about it, but those rings, we change our tools quite frequently, and we also clean the collet very frequently. And all I could think of was how much time that was going to take to have to move the collar, and it just wasn't something I wanted to go.
So why do you clean the collets a lot? Just so that they don't get crap in them and wear out more quickly, or?
Yes.
Okay.
But the collets, actually how we have adapted cleaning them, these are ER11 or ER8 collets. And the dust gets in there, shell dust, wood dust, it gets in there. And the more dust that gets in, the more the tool runs out,
Yeah.
which affects your tolerance. So I'll take the collet out. I'll take WD-40, paper towel, crimp it up so that I can spray it with WD-40, crimp it up so I can get it inside the taper, clean the taper. Then I'll take the collet and the nut itself and give it a shot of WD-40 and lightly hit it with air to get any of the debris out of it. Because, well, we'll use like a 30 thousandths tool diameter is our workhorse. We also use 20 thousandths shell cutters a lot and wood cutters, and we'll also go down to 15 thousandths. So if you find that your tool is breaking a lot, you might think about cleaning the collet, because those little tools don't like that. They let you know that they're running out. But pretty much every time we change a tool, we'll at least take the nut off and give it a little bit of a gentle air blast to get any debris off of it. If we have to hold tolerances, real tight tolerances, I'll do that whole WD-40 cleaning process. And believe it or not, when you measure the part, you see the difference. Yes.
How often how many operating hours are you running your collets and nuts before swapping them out? Like, do you track that?
It's in years.
Okay.
It's in years. The spindles that we use are water cooled, and typically we bought them from Alibaba. I was buying because we have multiple head machines, and so I was buying them 20 at a time, thinking that, well, it's Chinese, it's not going to last long, and it's water cooled, so it's going to rust. And in the first couple of years, we had these tanks of water, tubs, and these little pumps that you use in pools, like ponds or whatever. And the water got so nasty, and it gets really nasty. And of course, it plugged up the spindles, and I just ran them till they cracked. And then things evolved, but I mean, the price of a spindle was like $150. So I was thinking, well, if it goes a year, great, it's a throwaway. So we've evolved to a point now where we have gotten some laser chillers, and this is one, and I've gotten this antifreeze from West Marine that has rust inhibitors in it. And these chillers are totally enclosed, no dust gets in, and using the antifreeze, it doesn't have the contaminants that water likes to grow. I mean, there was stuff floating in there. It was nasty.
The tank's still over in the next room, and I'm the guy who got stuff cleaning it.
Oh, okay.
And I'm a nurse, and it grossed me out. So I understand.
Yeah, definitely wash your hands with bleach afterwards. So this has been a revolutionary thing for us. And so the end result was that instead of the spindles lasting a year, we're now on year 8. And I probably have about 40 or 50 years worth of spindles.
You're not replacing bearings or anything on them?
No, they're sealed. They're all totally sealed. So it's been we have 2 5-headed machines and a 4-headed machine and
3 5-headed machines.
So
we do have 3 5-headed machines.
But these are from China. What voltage are they? Are they like?
They are they you can buy the spindles by themselves, or you can buy them as a set with an inverter.
Okay.
And so the spindles typically are three-phase, but the inverter is single phase, which is like your house voltage. So you can take 220, which would be a house voltage, like for your dryer or your stove, and it converts it to the voltage. And of course, in the inverter, there's lots of parameters that you have to mess with to get things right. And but that's how it's set up. But can you go back to the five-headed machine? Oh no, that's going forward.
Here we go.
Yeah. So the what I did was the inverters are on the back side. I made a big box out of aluminum, and in there I put all the inverters, all the power supplies, all the fuses, all that stuff is in this box in the back. I needed to have a wire thing to hold the wires, like a wire track. And I thought, well, I don't want to have all these bulky things. So what I found was tubing, like air tubing. That was the idea of that was big enough so that I could put the wire all the way through it. And I secured it on one end inside the box and just cut a hole in the metal and had it as I go up. So they're kind of up and looped around, and you can see I just kind of used wire ties. Again, this is all MacGyvering now. And once it works, you don't have to touch it again. Or even make it better.
Yeah.
So you can see coming out of that tube is the wire that then goes into the motor. And I did that 12 years ago, and it's been working ever since, so I didn't have to do anything to it. Color coding, you can do your own. I happen to have yellow 8mm tubing that was required for this, so that's why it ended up being yellow. This stuff doesn't last a long time. It's lasted 12 years, and it gets brittle and breaks, and the antifreeze shoots out all over the place. So currently we have clear 8mm tubing, and that's on the first one.
I think Thumper had it.
Yeah, Thumper's got it. So these are still functioning, so they're still yellow. But yeah, Thumper's got it right there. So you can kind of see that it's clear, and you can see the antifreeze. Now our coworkers, I said, this is nice that it's clear now because sometimes debris does get in, and you need to disconnect the hoses and either blast it out. I found that I've got a solid copper wire that can actually get down in, and you kind of wiggle it around and give it an air blast to clear it. But I asked them to keep an eye on, if you start seeing bubbles, then we know that we need to clean it out. But
So go back to these dust collectors.
let's go back. We're kind of jumping around on this. But okay, we can go to collectors and containers. So we have, again, we got the Grizzly dust collectors because they were inexpensive, and they have worked well for us. Those are 220 volt or 230 volt single phase. I haven't integrated them into the machine where you turn it on with a button up by the station, because once we turn them on, they pretty much stay on. But one thing that we did was we put trash cans put underneath so that the liners, when you have a blowout, it's nasty. And what we found with the trash cans is when there's a blowout, it kind of seals itself against the wall of the can. But it lets you know that there's a hole in the bag, because it does come up, but it doesn't infect the entire shop. So that was a revolutionary idea that we came up with.
Do you have the top on the can with a,
Actually, you can buy them without it.
well, but I'm just looking, I see something on top of the trash can. I was wondering if you took a top and cut it, maybe it's just plastic.
Like the foam, is that foam?
Oh, this?
Yeah,
That's the collection bag.
oh,
So-
you put the,
So what we do is when we change the bag out, the bag is, it's just hanging there. So we just put the trash bag, make sure it's in there, turn it on, and it just goes and kind of seals it. Like if there's a hole in it, it almost seals itself against the wall of the can. I mean, it does kind of, it lets you know because the dust comes up and it tells you, hey, it's time to change me because I have a hole in me. But it's not blowing out through the whole shop.
how do you like those tops that you turn to kind of get the stuff out of the top canister?
This is an improvised filter.
Okay.
It's a towel. I did disassemble them and took some soft neoprene and tried to put some type of gasket in there. It doesn't seem to work. So some of them don't leak as bad as others. You can see this one over here has a towel on it too. But I like it because we also have what's the name of that other dust collector that begins with O? Oneida.
Oneida.
And that one we have to you have to have an air nozzle around the outside to get the dirt off the inside of the filter. You have to do that every day. Well, this one, I actually like this better because it really does clean the filter. Yeah. So this is an evolutionary dust collection unit that we came up with, and again, I had initially had all these HVAC fittings, like for your heating and air conditioning vents that either in the floor or the ceiling, and I thought they were the end all to everything, and it was great and inexpensive. So on this unit, there was one here, because we had three hose connections on these dust collectors. So I thought, well, the more connections, the better it's going to be. We put one here. We had two of them underneath, all sucking, and man, that's doing great. I would run a machine and just sit and just watch the dust. It was cool because they invented it. And but the dust was collecting around these suction holes. And I thought this was going to be the end of it because it was then blowing the dust right through. But it was just bumping off the back here and just falling down and collecting. And sometimes it would be an inch or two thick. And then if you hit it with some air blast from the front of the machine, even though it's all contained, it just like blow out. So that was how we. And I thought, well, let me just try making a hopper. Well, this is another, you can kind of see. We can go to the next one, you can probably see it a little bit better.
Is that caused by static electricity? If you ground that, would it stop that?
Possibly, but what I did do was I did ground them, not so much because of the dust, but the dust seemed to be creating some negative charge or some charge with the dust collector running. What was happening was the CNC machines were going into emergency stop mode. There'd be somehow an electric charge would cause them to, with the dust collector running, it would get a jolt and it would just like, we use Mach 3. So we use these very inexpensive, lousy XP computers that we've got about 15 of them in another room just waiting for the one on the floor to break. But, so I did ground it. Sometimes it seems to work, sometimes it doesn't. But, so this is looking at the front of the machine, that one that we were looking at. You can see I put a plexiglass wall up underneath and around to try and contain it, and these guys are blasting, and then you've got the dust collector in the back sucking all the dust in it, and the hoppers, that was revolutionary. The hoppers are revolutionary, so.
Can you talk about your work holding a little bit on that? Your work holding?
Sure. The material, this material is called Trespa. It's like a phenolic material, and it's got linen cloth in it. I think they use them. They're used a lot in labs for lab tables because they're stable. Once they don't seem to warp or move too much. I do have it bolted on top of an aluminum plate, which also helps support it. And so what we have here is a grid network where in this spot here, we can use it for fingerboards to vacuum down. This here, we can use it for head plates. And up here, we have a larger area that we use when we're cutting laminate.
Is there, you use a vacuum on this?
Yes. And what we've done in our shop is we have you could call it a machine room. It's where the air compressor is, the vacuum pump. And so that's another room. And what we did was we put a trunk line right down the middle of the shop and hooked the air to it. We have the compressed air is copper tubing, like water tubing with soldered fittings. And then we have a trunk line with a 3-inch diameter PVC pipe that goes down. And we have spiders that go out to all the different machines. And
Can I explain how you cut the channel and put Bondo?
oh yeah. So good idea.
So what's the name of the material that is the surface of
the gasket?
wagon?
Yeah, just gasket material.
Oh, okay.
So you're not drawing vacuum through that material, there's like a channel that you're
Yes.
sucking back into the channel.
So what I did in this case was the aluminum piece here, which is supporting the whole thing. I think it's like 25 by 30, and it's pretty thick. I wanted it to be. I overkilled it. It could have been thinner, but it's. What I did was I cut a channel this way with like a 1/2-inch end mill and milled out the aluminum and put a channel inside here, about this far back, and then tapped a hole on one end and for a pipe fitting, and that was the where the vacuum attaches to. And then on the top of this, which would be the Trespa, I drilled a hole in this way. This is a tuning knob, but it's actually a valve. So I drilled a hole in this way, and drilled a hole this way, and so that this is on the end of a tube that fits in there. So I can turn it one way, and the suction draws through the tube, and I turn it the other way, and it's blocked. So then what I had to do was get the vacuum out here. So what I ended up doing was milling with the machine, milled a slot, and put a piece of tubing. Again, you can get it from Granger or Big MasterCard, and put it in there and connected it to the end of this little tube this way. So when the tube rotated and the suction came through, it would suck through here. But now I had to cover up that tube because so I ended up using Bondo it smelled like a car shop for a day or two. And just fill it up, put it in there. It cures really quick, like maybe 10 minutes. And then it came time to surface the table, so I ended up putting router bits that were, they had a 1/4 inch shank and a 3/4 inch. They're really kind of, I think they're kind of dangerous, but they worked. And you can see the width of the cutter, and surface the whole table flat. So now everything's flat within relationship to the spindles. And then we ended up on our CAD system cutting out the areas where we wanted for vacuum. So and then anyway, help me here.
So then how does the vacuum, because you bondoed over the pipe with the vacuum?
Good question. In each one of these spots, well, you can see it here. There's a piece of foam that's covering a hole. I just would in each so there's a hole that's drilled here. You kind of see the little hole that's drilled there, and so there's in this case there's 2 holes. And when we're not using this side, I can just cover it over, and only that will vac.
That's a pretty simplistic approach.
Yeah, look, pretty much what you're looking at.
Yeah. There's a website I've got, vacuum clamping stuff. It's called Joe Woodworker. He sells veneers, but he has parts. And what I bought were like these little buttons. They're like when you press the button down, it allows the vacuum.
Mm-hmm.
But when it's snapped up, so only when you press down on the button, you're gonna get vacuum. So you can make a larger table,
Nice.
and you can have the buttons in there, but they're only gonna be activated when you press down on them, so.
Yes.
So if I'm seeing this correctly, it's like you have a channel that goes around your shape, and then you have like a round gasket tube. Is that kind of what's going on?
In here? Yeah.
Not in there, but like, do you have some sort of like tubing that is going within a channel?
Yes,
Not
there's
where
a.
vacuum is, but like,
Well, I cut it on our tables. I cut a channel that was probably 1/2 inch deep with an 1/8 inch end mill.
what I'm wondering is like, I see the white line, but to the outside,
Oh, out here?
The darker line.
Oh, this is gasket. Yeah,
okay,
this
so the
this
black
is
square gasket, right? The gasket material, I guess is what I'm asking about?
yes.
Okay, so when you put your piece on top of that, is your piece gonna end up touching the table?
Yes.
Okay, so it's gonna squish that gasket all the way out of the way, so that way you know that your piece is indexed with the top of the table.
Yes.
It's not like
In this case, these channels are. I think that they're about 60 thousandths deep.
okay.
And the gasket material, when it's new, it's about 125. It's about 1/8. So it allows it to. The gasket material is nice because it compresses, and the part itself is laying flat on the surface.
So what is that? What is that material?
It's called Trespa. When you're cutting it,
Are you
it's,
asking about the gasket
oh,
material?
the gasket material. It's
I'll look it up, and
Yeah.
I'll let you know by the end.
What
Yeah.
shape does it come in? Is it kind of rounded?
the gasket material.
The-
No, it's flat. It's
Do you know where we get it?
American Gasket Company. I mean, Chris.
What size vacuum pump?
We are running. It's really kind of cool. I think it's new. I think it cost about $2,500 with a motor. and we mounted it. Hey, Bear. We mounted it on a like you can get these air compressors that have their own, that have a tank on little wheels. Well, early on, we burned through quite a few air compressors. And so they're sitting there doing nothing. So I unbolt the air compressor, take it off the tank and get rid of it. Now I have the tank. So what I do is I take the vacuum pump and put it on top of that tank. And now it's converted from an air pressure to a vacuum pressure. And it does a great job. But the one that we have, I don't have the name of it, but it's oilless. And it's used in hospitals. And it has these carbon vanes inside that rotate. And we run every day, 8-10 hours a day, every day of the week. And they last probably about 3 or 4 years before the carbon vanes self-destruct. And then there's kits that we can rebuild it with pretty good. But it's dry. There's no oil in it, and it works really quite well. The other thing that we've done that helps the life of the vacuum pump is we got vacuum filters from a company in Massachusetts and again, I think it has to do with the medical field. But they're just these big things that canisters. They have a filter in it, and we should clean them more often, but I really only clean them about once every 3 or 4 years. And the canister unscrews, you take the filter out, just go to another dust collector, blow all the dust off of it, reassemble it, put it back together. But that has saved our vacuum pump dramatically.
So this is like an inline unit?
We actually put them on each machine. They're quite expensive. They're about $400 a piece. But we put them on each machine so that the dust doesn't get into our whole system. And it's been, I don't have pictures of it. I knew it was gonna,
What is it?
Vacuum filter.
So you're not filtering the air going into the vacuum pump, it's the air coming out? Correct?
Yes.
So
Well,
you've got your filter right at your machine?
right at the machine.
Okay.
And that saved, well, I mean, to repair the vacuum pump, it takes time and cost, so I don't know how we came upon that idea, but we did. and it's been, that one's been,
Here's the back of your machine.
yeah, this is the back of that box where all the electronics are in it. And we have these grates here are just big holes that I cut out, and I put as a filter, I put it's an abrasive material that you can use to clean stuff with. It's called, I'll think of it. Thank you. So there's just Scotch-Brite in the back of these things, and we have power supplies in there, the inverters, all kinds of electronic stuff that creates heat. And so this was just a way of opening up and venting it without having to put fans. Those holes that were cut there with the little plastic covers, it's so that you can get into the inverter. And sometimes you need to change the RPMs or change a parameter, and so that allows you to get in there without having to remove the whole cover off the. And we have some people that like stickers, so they put stickers on all our machines.
Thought it was a Frisbee for a minute.
On the 5-headed or the multi-headed machines, I got light switches that can handle 220 volt. And So each inverter has its own light switch. So when we're running 5 spindles, we have 5 switches on, and when we're running 1 spindle, we have one spindle on, because we just have one command, an M3 command, to turn on the spindles, and that's a relay that sends a signal to the inverters. So if the inverters are on and you tell it to program the machine to turn on, they're all going to turn on, which can be dangerous if you're only running 1 spindle. So that was the idea behind the light switches.
Is that what you're talking about? No.
This is, go back to it. This here is the vacuum filter. And the bottom of it just twists off. And, well, you can see it's not clear, it's full of dust. This here, before we had a air compressor, we have a rotary air compressor with a chiller on it. Prior to that, we had a non-rotary, it's a piston air compressor. And when it runs all day long and it's humid, it generates a lot of water. And so our parts really don't like water. So I tried everything I could. I spent enough money to buy an air compressor on water capturing, and that's what this thing is. It didn't work. So we ended up biting the bullet and got a rotary air compressor, and we pay the maintenance, the inspection fee, and it's like an insurance policy that we pay the money. It's expensive, but if something breaks, I just call them and say, hey, I don't want to know anything about this thing. I paid the insurance, you come out and fix it. It's well worth the money. Yes?
Just speaking about humidity, are you running humidity control in this whole facility like Mark does? Like do you have a giant dehumidifier and things like that for your
Tell them
tolerances?
about our bags.
Yeah, well, yes, we do.
I'm just curious, because you're talking about things don't like water, and you're working to keep the water out of everything else.
Well, we have a low-end humidity control system for the wood. It's giant Ziploc bags. Whenever material comes in,
I like,
it goes into the Ziploc bag until we need it, and then as soon as we're done with it, it goes right back in it.
Good solution.
We can go to, we can jump ahead to the new machine. I mean,
Okay.
let's see what.
Here's a picture
where
of
are
the
we?
XY slide if you want to.
Yeah, let's.
so basically, your whole shop is MacGyver because you've customized all this stuff, right?
Not really.
This guy, this is a good one.
Because you can't necessarily just order this stuff all set up.
No,
Right.
no, you can't. Yeah, well, I found that these little stepper motors were getting too hot, so I ended up getting some heat sinks, and they had stickum on them, but when they get warm, they kind of fall off. So
Are these from like a CPU on a computer?
I didn't, not that far. I mean, I do stuff like that, but no, these I actually purchased. Yes,
And so it cooled them down.
yes.
If you wanted, I actually have a 3D model of a little fan mount to go on top of the steppers. It's in my email because we needed it for next door. So just if you want, I never got to use it. So.
No, it's okay. I'm good.
You know,
Thank you.
Concerning fact of having, like, I have a shop bot, and there's really not any kind of information on maintenance of, like, okay, if this starts, what am I supposed to do to make sure this thing keeps running?
Right. Well, one thing that I've found, because in the automation business that I was in another life, everybody wanted the latest, greatest stuff. They wanted AC servo motors, and they wanted all this really neat stuff. And, but what I found for us, you know, having been in the field and done it for many people, it became a great maintenance thing because needing to be able to, you know, like when you build a machine you get paid once. When the thing breaks down, you get paid again and again and again and again. And I found that stepper motors, once they came out with stepper motors that you could get micro steppers, it gave you the same resolution as you could get from servos. And there's 4 wires, they're totally enclosed, they run forever. Unlike a lot of the servos where you've got like 6 or 7 wires for feedback, a couple of wires there for the motor, maybe 3 wires for the motor, and then if it's a DC servo, you got the brushes that wear out. So cost, and that's why I chose steppers, because it's worked fine for us. So this is a machine that I have in process now, and I'm spending so much time trying to figure out how to keep dust out of it. And I'm in this case, I'm working on, the picture shows I'm working on this, and I'm trying to create chambers inside. I guess we go to the next one, it shows it a little bit better. So it's a little bit afterwards, I've created an area where it has a bottom underneath this, and I've got some sides, and I can put the bellows on top. So I've created a chamber in there to try and keep dust out of. And what I have done on other machines like this is once I have this chamber created, I'm not trying to keep dust in this, I'm trying to keep the dust out of this, where the other chamber I was trying to keep dust in. So once I have this chamber created, what I do is I put dry compressed air in here. So I basically just have a hose in there with a, with like maybe 5 or 10 PSI. So I have to have a regulator for it. And it puts air pressure inside this chamber, inside the table or the machine. And what it does is it makes it less likely for the dust to want to get in there, because there's air always coming out. And you can see it pretty good here. Now if we go to the next one, and another one, and another one. So now what I've done is I've had to take this apart, because now I'm working on the chamber for this one here. And you can see that there's a little MacGyvering going on. But if we go to the next one, yeah, you got all kinds of tools. And if you go to the next one, this is what it's going to look like. Where we have an enclosure that the neoprene can ride on. We got some rollers here, and this machine, it has dust. When we're running, there's dust everywhere. All over it. And it's been in operation for, I don't know, at least 6 years. And this is what it looks like inside. So that air pressure really does work. And
Almost 2 o'clock.
thank you. Chris, I'm sorry.
Where do you source most of your end mills?
We get them from Think and Tinker, Precise Bits a lot. What was the company in Massachusetts we get from? Harvey Tool.
BQ Tool is also a good little place. Now, if you're using a shell cutter, I do a lot of wood.
Yep.
And BQ Tool is probably the most affordable, and they make them from 20 thousandths on up. Very good people to deal with.
Great.
Perchette Quality Tool, BQTool.com, you can find them. They make a 20,000 bit on up. And it's a solid carbide end mill, and they work very good.
Thanks for the tip on cleaning collets.
Yeah, it's because people ask me, why is my bit breaking all the time? I said, have you ever cleaned your collet?
Can I add one point there? For all you guys that are gonna get into CNC, because I did this I'm so used to the machinist handling R8s, make sure you snap your collet into your collet nut. Because if you don't, you're gonna incorporate uncontrolled running.
Do you have a question? Okay. Thank you very much.
Thank you.